Hello and welcome. My name is Kip Kasherba from Sandalwood Engineering and Ergonomics, and I am the technical lead on the injury prevention team. This is session 2124, Integrating a Digital Human Model into Your Business. During this presentation, the term Digital Human Model and the acronym DHM will be used interchangeably. I hope that you're enjoying the virtual conference experience, and thank you for attending this session. Let's get right into it. Digital human modeling, or DHM, has developed and evolved over the past 50 years to become the amazing, highly capable tool that we have today. We went from rudimentary representations of the human as a stick figure, to blocks, to mesh, to smooth skin and truly human-like digital representations. Throughout this transformation in visual accuracy, the capability of the human was continually upgraded. What started with fully user manual inputs to manipulate and posture the digital human evolved into predictive and intelligent models backed by decades of motion research, along with further research on actual human behaviors while accomplishing tasks. Today's DHM is capable of reacting and adapting to external and internal stimuli to predict an appropriate human behavior. But what is considered a DHM? Confusion starts with DHM versus avatars. Computer-generated avatars can look really cool and are pleasing to the eye, and that is in essence their purpose, look good. Motion captured from real people can be applied to a computer rendering of a character or avatar to display human-like behavior. However, they are not based on any real human anthropometrics, and in fact are often intentionally distorted from actual human forms. DHMs are digital representations of real humans, based on the proportions of real people, and many have the ability to react how people would actually react. An advanced DHM can posture itself using predictive algorithms that can account for user-applied and intrinsic limitations, along with one or more task parameters. These algorithms are developed using research on actual human behavior. Simply put, a user can ask the DHM to complete a task, and the DHM will predict how a real human would do it. In order to obtain buy-in for digital human modeling implementation, it is important to understand what you would be getting. The power of DHM implementation is unique to each company and each use case, but this is where the future is going. The digital transformation of the world is happening. Realize the power to relay a risk of injury or a critical impact to the user experience visually using a DHM. It's the power to change minds and make a real difference. DHM can be part of the design and engineering process. You don't need to look at human factors in a vacuum or on an island. You can have the human integrated into your virtual engineering world seamlessly. The benefits of utilizing digital human modeling are many and more and continue to emerge as use cases extend into new industries. Some major categories are called out in the next slide and can be used as a foundation to build from based on your organization's vision, objectives, and primary drivers. The following foundational categories can all benefit. Each organization can find their own way to utilize digital human modeling. One effective way is to tie into your main drivers as an organization, whether that be safety, quality, time to market, cost, or anything else. Whether you're designing a product or designing a system, odds are that a human will interact in some way. So understanding how is a logical input. There are benefits to product design and benefits to manufacturing, and it is important to not lose sight of the differences. It is also important to note that the earlier on in the design phase a DHM is used, the greater the potential benefits. With respect to optimization, the visualization of your process can help you evaluate the layout, identify constraints, assess workflow, all prior to implementation or physical build phase. DHM permits all of these same advantages while also accounting for the capabilities and limitations of human users. For example, With human-centered product design, you may achieve longer use time with a piece of equipment without fatigue or injury. In manufacturing, digital human models with dynamic simulation power, such as TSB or PS, can help determine the amount of time required to pick parts from line-side racks in vehicle assembly. This helps to make a workstation more efficient and productive. In design, assess a pilot's reach to buttons within a cockpit, placing the most often used or most critical emergency buttons in easy-to-reach areas and other less commonly used and less critical buttons in other areas of the cockpit. As another design example, digital human modeling can be used to assess wrist posture and strength capabilities in the design of a handle on a new tool, such as a nail gun. Safety. Many things to consider here. Clearance, pinch points, line of sight, assessments of the effectiveness of guarding. In manufacturing, digital human modeling can help determine requirements for head clearance when working in a tight area and identify human interaction with moving components. In design, it can evaluate line of sight to pedestrians and other vehicles from the point of view of a driver of a vehicle in accordance with government line of sight requirements. Musculoskeletal injuries. Imagine identifying ergonomic concerns of reach, strength, and clearance during design, allowing modifications to be made or countermeasures developed without the cost of redesigning, without the cost of injury claims, and without the cost of turnover or absenteeism. In manufacturing, we can determine the strength capabilities of an appliance maintenance worker in a typical posture, such as reaching to install a hose behind a washing machine. Strength capabilities can help set an insertion force target for the hoses. In design, we can obtain quantitative data to validate the design of a snow shovel for consumers that promotes a posture which reduces low back compression. For quality, in the most basic sense, an easier task is more likely to be completed without error. Proper layout of a workstation, sequencing of product that optimizes human performance, and human-friendly part design all helps to improve quality of work, to limit repair, and avoid warranty or recall. In manufacturing, an example would be using digital human modeling to determine the sequence of assembly of hoses to an engine by assessing hand clearance to surrounding components and other hoses. By providing adequate hand clearance for an operator's hands, the likelihood of damaging the surrounding hoses decreases, and the likelihood of fully installing a hose increases. In design, a similar example would be using a quick connect hose attachment rather than rubber and clamp attachment in locations where access and/or visibility is restricted. All of these benefits tie into one further benefit that every organization is interested in: decreased costs of waste, of labor, of injury claims, of defects, and of course, of redesign to fix what didn't work. Using digital humans saves companies both money and time when considering various design alternatives and increases the chance of getting it right the first time. Of course, implementing DHM is not without cost. It may require new software or additional licensing to software, as well as a qualified user. But as identified, there are many opportunities that will yield savings. Optimize your process, eliminate risks to worker well-being, reduce employee turnover and absenteeism, identify critical quality concerns. With DHM, you are capable of anticipating issues, space constraints, workflow problems, ergonomic concerns, and then you have the opportunity to come up with changes before virtual concerns become real-world problems. Thus, the further upstream we consider the human, the greater the potential benefits, and ultimately, the greater the cost savings. Okay, now that you are convinced that it's worth it, how should you implement digital human modeling? First, establish your purpose. What problem are you looking to solve with digital human modeling? Is it fit, reach, clearance, strength? How about product design or manufacturing? What aspects of your business would be served best by taking advantage of the benefits that digital human modeling offers? Next, look into existing software. Look to your IT and engineering counterparts to see what software they use and ask if a human is available. It may be that you are already paying for a digital human model but aren't taking advantage yet. Then comes validation of your purpose. Maybe you're looking to establish strength capability to reduce injuries. Maybe you need dynamic simulations to assist with process planning. Does the human within the software suite answer the questions you are asking? This, of course, requires an understanding of what capabilities the human has and which pieces can impact your purpose. Here is where you decide if an appropriate human is embedded in existing software that you already use within the company, or if you need a separate software to answer your questions. There's a variety of digital human modeling software available, each with its set of proficiencies. Don't be intimidated. The degree of integration and depth of use can be an iterative process and one that evolves along with your business over time. Next is establishing gateways. Set engineering or corporate gateways where the human must be considered and verified for compliance to your purpose. Whether you export info into your standalone digital human model, or you utilize the human within your existing software that is already being used for virtual engineering and planning, get the human factors a seat at the table. This can also be baby steps, so maybe the human is not fully embedded or totally simulated. Perhaps static models are imported at specific times in the design phase, and that is a great start. Next, feed into existing metrics. Tie your purpose to corporate objectives and help everyone win. This also helps to track your success in a meaningful way. And finally, innovate. If the software can't do what you want it to do, push developers to improve it. Datasets and methodologies continue to be developed, and the digital human market is becoming more competitive. So many developers will be keen to be on the forefront and are always looking for an edge. Additionally, push your engineering team to think differently about the human. Get them to view the human user as the customer. Be creative. Push yourselves to think about different ways to consider the human to make the most difference for your business. Some key takeaways are called out here on this last slide. The first, the power. Understand the power of digital human modeling and use that power to sell the benefits. Change minds and make a difference. The second, cost savings are achievable in many ways using digital human modeling, but integration into early design phases will yield the greatest benefit. Establish a purpose for digital human modeling that will get the human considered cross-functionally and help everyone win. Take baby steps if needed and evolve the DHM integration over time, but just don't be intimidated to start. And finally, innovate and be creative. Question, provide feedback, participate within your business and with software developers. Thanks so much for attending. I hope you enjoyed the content and that the wheels are turning already. Don't forget that you can join me to continue the conversation later today, 2:45 to 3:15 p.m. Eastern. Thanks a lot.